So this is question number 40 of GATE 2022 Metallurgical Engineering. We have been given different types of dislocation reaction in the column A, and in column B the description of this dislocation reaction is basically mentioned. So we have to match the right option in the column A with the right option in column B. So we'll go one by one. So the first dislocation reaction is as you can see here, two partial dislocation are merging to form a complete dislocation. Now if you see the first option in column A, which is a dislocation reaction giving rise to different types of dislocation. So by looking at the reaction, you can at least say that this dislocation is moving in 111 direction, right? And this 1 bar 1 direction is basically lying in 101 plane, right? And this dislocation is lying in 101 bar plane, right? In BCC, slip occurs in 111 direction and in 110 set of planes. Like most of the time, slip in BCC occur in this direction and this set of planes, right? So if you try to represent this dislocation reaction, we can write it like two partial dislocation are moving in this way, and they are combining to form another complete dislocation. So this can be A0 times 0, 0, 1, and this can be A by 2 times 1 bar 1 bar 1, and this can be A0 by 2 times 1 1 1, right? So these dislocations are basically merging and forming this, and this is happening. So this plane is nothing but our 101 plane, and this plane is nothing but our 101 bar plane. And finally, after merging, this dislocation A0 001 is lying in. So this is a typical dislocation reaction in BCC, right? Which is option P. So the right option for P will be 3. Now coming to the option Q. Now if you see the option Q, so two dislocation are merging to form a new dislocation, which is nothing but A0 upon 6 0 1 1. So if you closely analyze this final dislocation, so the new dislocation basically lies parallel to the line of intersection of the slip plane, and basically it is having a pure edge character in 100 plane, right? So such type of like dislocation reaction basically occurs in FCC, right? And two dislocation here combine, two mobile dislocation basically combine to form an immobile dislocation. So this is basically the final dislocation which is forming here is an immobile dislocation, and we can also call it is a sessile dislocation. Because its Berger vector does not lie either of the planes of its stacking fault, right? So this final dislocation is a sessile or immobile dislocation, and it is also called as a Lohmer-Cottrell lock in SSC metal. So the right option for Q will be option 1. Now if you see the option R, so two dislocation reaction is happening. So if you try to calculate the energy of dislocation on LHS side and RHS side, so at LHS the energy of dislocation will be basically given by the magnitude of Bajor vector square, right? So the magnitude of Bajor vector will be 1 upon 6 under root 1 square plus 2 bar square plus 1 to the whole square plus 1 upon 6 under root 1 bar square plus 1 bar square plus 2 square to the whole square. So if you solve this, you will get 1 upon 36 into 6 plus 1 upon 36 into 6. So basically 12 upon 36 or 1 upon 3, right? Now for right hand side, if you try to calculate the energy of dislocation, it will be 1 upon 2 under root 0 square plus 1 bar square plus 1 square to the whole square. So it will be 1 upon 4 into 2, which is 1 by 2. So you can easily say that RHS is greater than LHS, right? So by undergoing this reaction, we are basically increasing our energy. So from energy point of view, this reaction is not favorable, right? Because the energy is increasing from 1 by 3 to 1 by 2. So it is basically energetically unfavorable dislocation reaction, and that too in a FCC type of material. So if you summarize, for P, third is the right answer, for Q, first is the right answer, and for R, second is the right answer, right? So P3, Q1, R2. So the option B is a right match from column A to column B. Thank you.